Okay, so today we're going to be doing a little bit of what should be review for most of us from algebra, the Pythagorean theorem, which you've probably done multiple times in middle school, and then also doing a little bit of trigonometry, which we should have done last year as in Algebra 1. So first with Pythagorean theorem, just with right triangles, a squared plus b squared equals c squared. Everyone knows the formula. Just make sure the one thing that we screw up is figuring out which length of our triangle is the hypotenuse. So your hypotenuse is always across from the right angle. So in this triangle right here, the way that I always do this is I want to circle my hypotenuse as the first thing that I always do. And this will help us when we're doing this, and then also when we do get to using trig, identifying the hypotenuse first will help us. So the one that's across from my right angle is going to be my hypotenuse, so C is my hypotenuse. With this first problem right here, again, my first thing I do is find my hypotenuse, so 13 is my hypotenuse. So when I write this, I can go 5 squared plus b squared is equal to 13 squared. And so I get 25 plus b squared is equal to 169. Subtract the 25, and so I get b squared is equal to 144. And then I take the square root of both sides and get b is equal to 12. To take a square root of a number in your calculator, you hit the second button and then hit the x squared button if you're using a graphing calculator. With the second one, again, same thing. Identify the hypotenuse, which is 15. So I want to go a squared plus 12 squared is equal to 15 squared. So I get a squared plus 144 is equal to 225. Subtract the 144 to get a squared is equal to 81. Take the square root of both sides, and so a is equal to 9. Again, fairly easy. You're just solving for the variable. With the second one, so one thing that we know is if we're given three lengths of a triangle, so 3 of the sides of a triangle, that we know that if a squared plus b squared equals c squared, then the triangle has to be a right triangle. So the thing that we need to know is that the longest side is always the hypotenuse. So with both these problems, again, I'm going to identify the hypotenuse. In this first case, it's going to be 10, so I'm going to circle it. So I'm going to do 4 squared plus 8 squared is equal to 10 squared. And so we know that if both sides are the same number, if they're equal to each other, then it's a right triangle. So I've got 16 plus 64 is equal to 100. So this is 80 is equal to 100. It's obviously not true, and so this is not a right triangle. With the second one, same thing. Largest side length is 26. So I'm going to go 10 squared plus 24 squared is equal to 26 squared. So I get 100 plus 576 is equal to 676. So 676 is equal to 676. That's true, so yes, this is going to end up being a right triangle. And then the last thing that we have is we know that, again, our hypotenuse, which is c squared. So if my largest side length, if it's greater than, I know that it's going to be obtuse. And then if the hypotenuse is less than, it's going to be acute. And so the way that I can do this is again, just see whether my hypotenuse is bigger or less than. And so when I do this, again, I can circle my 9. That's going to be my C. And so I can go 7 squared plus 8 squared. And then I want to figure out what it is, 9 squared, whether it's bigger or smaller. And so I get 49 plus 64. And 81, and so I get 113 and 81. So 113 is going to end up being bigger, And so again, just by looking at my rules, if a squared and b squared are bigger than my c squared, I know that it's going to be acute. So this is going to be an acute triangle. Remember that this is my hypotenuse. And so if it's smaller than the other two, then I know that it's going to be an acute triangle. Same thing with the next one. 14 is going to be my hypotenuse. So it's going to be 6 squared plus 11 squared. And I'm trying to figure out whether it's bigger or smaller than 14 squared. So I get 36 plus 121. And then I've got 196 on the other side. So this is 157. And 196. And so I know that 196 is bigger, which means this is going to be an obtuse triangle. So that's all for Pythagorean theorem. Now we can jump over to trig. So whenever we're talking about trig, that's sine, cosine, and tangent, the buttons on your calculator. I guess before we get started with that, make sure that you're doing these calculations with me on your calculator. So if you're watching this video, have a calculator handy. Make sure that your calculator is in degrees. So if you click the mode button up in the top of your calculator, make sure you go down to where it says radian and degrees, and make sure that we click it on degrees, because we need to make sure that we are doing degrees of angles, not radians of angles. And so that's important to make sure that you're in the right mode, or else you'll get wrong answers. And so when we do this, I've got 3 different trig ratios. I've got tangent. So tangent is opposite over adjacent. So when I write it, I'm going to do opposite over adjacent. And so if I look at, so when I'm doing this, I'm going to be using the words opposite, adjacent, and hypotenuse. So opposite, write yourself a little note off to the side. Opposite means across from. Adjacent is going to mean next to, but not the hypotenuse, not the hype. So next to, but not the hypotenuse. So again, the first thing that I want to do with this problem is I want to identify the hypotenuse, which in this case is 10. So 10 is my hypotenuse, and so this is saying the tangent of A, which means I'm going to start at angle A. So I'm going to start here at angle A, and I want to find the sides that are opposite and adjacent. Remember that opposite means across from, so the side that's across from it is going to be 8. And then the side that is adjacent to angle A, but not the hypotenuse, so next to but not the hypotenuse, is going to be 6, which reduces down to 4/3. Sine is the next one. Sine is opposite over top of my hypotenuse. So when I write this, I'm going to go opposite over hypotenuse. And so again, starting at angle A, the side that's opposite of angle A is going to be 8. And then my hypotenuse is 10. So that reduces down to 4/5. And then the last one is cosine. Cosine is adjacent over hypotenuse. So I'm going to write it as adjacent over hypotenuse. And so the side that's adjacent to angle A, so next to but not the hypotenuse, is 6. And then the one that's across is going to be 10. So that reduces down to 3/5. Okay? So again, just using those same words, I can do the same thing with the bottom to find the tangent of B. So all that changes is just the fact that instead of starting at angle A, I'm going to start at angle B, the red angle that I just put down there. And so if I'm doing the tangent of B, Tangent means opposite over adjacent. So from B, opposite is 6, adjacent is 8. So tangent of B is 6 over 8, which is 3/4. The sine of B. Sine of B means opposite over hypotenuse. So from angle B, opposite is 6, hypotenuse is 10. So it'll be 6 over 10, or 3 over 5. Cosine of B is adjacent over hypotenuse. Adjacent to angle B is 8. Hypotenuse is 10. So I can go 8 over 10, which is 4/5. With each of the bottom, tangent of C, sine of C, cosine of C, cross them off. We can't ever use trig to go from our right angle. So we can't do any of those. Just write can't do. And so what we can do here, flip over to the back, is I can use trig to go ahead and help me solve my equations to find missing lengths. So what I want to do here is I'm going to go ahead and write in my values. So I've got angle A is a 43-degree angle. This A right here is 6 meters. And I want to figure out what B and C are. So to do this, I'm going to write an equation. So what happens here is I will go, I'm always going to use the angle and one of the sides that I'm given to find one of the sides that I'm missing. And so I'm going to use this 43-degree angle. I'm going to use this 6-meter side. And then let's go ahead and find out what B is first. And so using those three things, what I have to do is I have to figure out which trig function I'm going to use. So from my 43-degree angle, C is going to be my hypotenuse, so I'm going to identify that first, just like we did on the other side. The 6-meter side is across from the angle, so that's going to mean opposite, so I'm going to put OPP. And then the side length B is going to be my adjacent side. And so the three things that I have, the 43-degree angle, the 6-meter side, and B, that's using my side that's opposite and adjacent, so I'm going to use tangent. So it's going to be tangent of my angle, which is 43, is equal to opposite over adjacent, which is 6 over B. Just a little note here, this is always my angle, and then on the other side will always be my sides. And so once I write my equation, then I'm just solving my equation to find my variable. So I'm going to solve for B. The way that I do this is I'm always going to multiply both sides by whatever's on the bottom. So on the bottom is my B, so I'm going to multiply both sides by B. So I get B times the tangent of 43 is equal to, these B's cancel out, and I'm left with 6. Again, to solve for my variable, I'm going to divide both sides by the tangent of 43. And so I get B is equal to, in my calculator I'm going to type in 6 divided by the tangent of 43. You'll find your sine, cosine, and tangent buttons 2 rows above your 7, 8, and 9. So you go tan 43 and close your parenthesis, and so you should get 6.43. So again, I want to be able to, I'm always using the angle, I'm always using a side that I'm given, and then I'm using a side that I want to find. So with the second one, I'm going to go ahead and put a 21-degree angle in for B, right there, and then I know that the lowercase a is going to be 22. And what I want to do is I want to figure out what my other lengths are. So in this case, I'm going to go ahead and I want to figure out what C is equal to. So I'm going to use the 21-degree angle, I'm going to use the 22-meter side, and then I'm going to use the one unknown. So I'm using those three things right there. Again, I want to label these. So C is my hypotenuse from the 21-degree angle, B is going to be opposite, and 22 is going to be my adjacent. And so, again, the three things that I've circled in red, the 21-degree angle, the 22-meter side, and the C side, I want to use those three things. So the 22-meter side is my adjacent, the C is my hypotenuse, and so that means I'm going to use cosine to figure out what C is equal to. So I'm going to go cosine of 21 is equal to, and it's going to be adjacent over hypotenuse. So 22 over my hypotenuse, which is C. And so what I can do here is I can go ahead and solve my equation the same way. Multiply both sides by C. C's cancel each other out. I'm left with C times the cosine of 21 is equal to 22. And then divide both sides by the cosine of 21. And so I get C is equal to 22 divided by the cosine of 21. I get 23.57, if I'm rounding correctly. Okay? And I can do the same exact thing if instead of wanting to find out what C was equal to, I can do the same thing to figure out what B is equal to. So I can write another equation to figure out what B is equal to. So I'm still going to use my 21-degree angle. I'm still going to use the 22-meter side. Now I'm just going to figure out what B is, so I'm going to circle B right here. And so in a separate equation, I'm going to erase this other one so I have room. What I can do is I can solve for that. So I can go with using those three red things that I circled, the 21-degree angle, 22-meter side, and B, I have sides that are adjacent and opposite, so I'm going to use tangent. So I'm going to go tangent of 21 is equal to opposite over adjacent, so B over 22. And so, again, there's my equation, writing it using my sine, cosine, or tangent. In this case, I use tangent because I had opposite over adjacent. Then write my equation. It's opposite over adjacent. Then I can go ahead and solve my equation. So multiply by whatever's on the bottom. And this one's easy. It's just 22 times the tangent of 21, which gives me 8.45 is equal to B. And that's where I'm going to stop. I'm going to save the other two problems for tomorrow. Again, just remember, when you're writing your equation to solve for a missing side length, you always have to use three things. Two are things that you know, so actual numbers, and then one unknown, which is your variable.